Hi, I'm Josh, and today I want to review a very useful tool in Java that you might not be aware of. If you don't know, streams were introduced in Java 8 as a way of simplifying data manipulation. It's common while programming to run into situations where you have to collect data, manipulate that data in some way, and then convert that data into a specific output format. You can do this manually, but streams provide a very powerful interface for dealing with many of the situations you're likely to run into. Imagine you're trying to find all the even numbers in a list. In the old Java, you would go through each element of the list, manually check to see if it's even, and then manually add it to a new list. With streams, this all changed. They provide a scalable interface that allows you to chain multiple operations together. There are 3 stages to every stream. First, you create the stream. Then, you can optionally use one or more intermediate operations to transform the elements. Finally, use a terminal operation to produce a result, which can be a list or a singular value. Before we go further, I should explain what a lambda function is. The lambda function is just a convenient way of writing a Java function. Instead of including type notation, method names, and access modifiers, you just provide the arguments and the method body. Often when you're using stream functions, you will pass lambdas instead of regular variables, so it's a good idea to get comfortable with this notation. There are many different ways to create streams. For a Java list, you can use the stream method. This method is present in all implementations of the Java collection interface. If you're using a primitive array, use the static of method of the stream class. Streams can be infinite as well. In this example, we pass a method reference to the random method. And here we create an iterative stream that begins with an initial value and applies a given lambda with each iteration. If you want to use multi-threading, create a stream with the parallel stream method. Doing this spreads the computations of the stream out over different threads. Be warned though, unless your dataset is very large, the overhead from this will slow your code down. There are 2 main types of stream operations: intermediate operations that act on your data, and terminal operations that collect your data into some useful form. Let's go over some that you're likely to run into. The filter operation filters out elements of the stream that do not match a given predicate. In this example, we provide a lambda that filters out all elements less than 5. The map function transforms each element of your stream with a given function. Here, we convert the elements of the stream into strings that are all uppercase. You can get unique elements of a stream by calling the distinct method. You can sort the elements of stream with the sorted method. Here, we sort from low to high. You can also provide a custom comparator. You can use the limit method. This limits your stream to the first n results. In this example, we take the first 3. To terminate a stream, you have to convert the data into some useful form. The collectors class provides a bunch of methods to do so. For example, here we convert the stream into a list. Similarly, if you wanted to convert the stream into a set, you would use the toSet method. Or you could add up the sum of a stream of integers with the summing int collector. These are just a few ways you can collect a stream. It's worth noting that streams do not alter the underlying data source. A completely new collection is created after you call a terminal operation. You can reduce a stream by providing a lambda function. The reduce function operates on each element of the stream until you have a single element left. And finally, the count method returns the number of elements in your stream. For example, here when we add up each element. One important thing to note about streams is that they are lazy. The operations chained together into a stream do not execute until you call a terminal operation. In this example, the filter and map operations do not begin until you call the collect method. Let's put this all together with an example. Imagine you are interacting with a database and you want to find the top 3 highest paid engineers at a company. You could do this with a stream by first filtering the list of employees. You could then sort that list with a custom comparator. Then you could limit your list to the top 3, extract the name with the map function, and collect the results into a list. There are many other things you can do with streams. so I encourage you to check out the documentation I link below. Streams are most useful when you're processing collections that are large enough to benefit from parallelism. If you're working with small collections, or need to modify the state of the collection, use a traditional for loop. It's best to master both approaches to maximize your flexibility. Thanks for watching. If you thought this was useful, or want to see more content like this in the future, give the video a like and a subscribe. If you have another topic you'd like me to go over, leave a comment. I'm happy to take suggestions. Until next time.